What is the functionality of an error amplifier, and why do we need a negative feedback loop in a switch mode power supply or even in a linear power supply? These are the two main questions what we gonna answer in today's video. Welcome to Donkey Learning IT, where Dr. Donkey will teach you various topics in IT and applied electronics. Let's go! In the 9th episode of the switch mode power supply repair series, we have introduced this circuit where there is a series resistor put in series with a Zener diode. The Zener diode is then producing a reference voltage, and this reference voltage is then put on the base of a power transistor, where the power transistor is operating in the emitter follower configuration. After a series of measurements, we have concluded that combining the Zener diode with the power transistor is just not good enough. Due to this large deviation of almost 9% when it comes to the output voltage, the conclusion is that the simple circuit cannot be used in practice when it comes to stabilizing the output voltage. So practically this means that this output voltage what we are measuring here is just deviating too much when we are increasing or decreasing the input voltage. At this stage we have to ask what could we do to improve the stability of this power supply. In particular, to improve the output stability. Before we are doing any changes to the current circuit, let us first think about it, what could be potentially missing or what could be wrong. So here the input voltage, we know it will change. This is why we are using here this Zener diode to provide us a relatively stable reference voltage. So it means that we are one way or another monitoring the input voltage. So far so good. However, we have to keep in mind that the voltage what we wanna keep stable is the output voltage and not the input voltage, since the input voltage will change anyway. Okay, so we established that we have the output voltage here and we are not monitoring it at all. This of course means that we do not have any control over the output voltage, which is clearly no good. Therefore, we must put in some extra components in the output where we are monitoring the output voltage actively. Furthermore, we then have to have a way to tell this power transistor the input voltage have changed. So now, in order to have the same stable output voltage here, you must then also change the resistive value between the collector and the emitter electrode. Also, if the load changes for some reason, we also have to tell the power transistor that it needs to adjust this resistive value between the collector and emitter accordingly. As a long story short, we have to monitor here actively the output voltage, and as a function of the output voltage, we have to send back some signal to the power transistor such that the output voltage will then be stable. As a real-life example for a control loop, where we are controlling the output of something, we will use here this person as an example who is taking a shower. So this person here would like to then adjust the output such that the water coming out here from the faucet is then 30 degrees C. If you are following from some non-metric countries, that is about 86 degrees Fahrenheit. So then let us think about it. If you just open one of the valves, either the cold water or the hot water, will you get 30 degrees? The response is most likely not. And that is because the hot water will be considerably warmer than 30 degrees C, and the cold water will most likely be a lot colder than 30 degrees C. Compared to our electronic circuit, this expected value is the value what we wanna have on the output. In this example here we have some Celsius value, however of course in a circuit we will most likely have some value in voltage what we wanna have on the output. Also, in this case the output is this shower head, whereas in the circuit the output was the emitter of the power transistor. When it comes to the cold water input that is fed in by some reservoir from the outside, right here is winter, so it is almost freezing, and it is really optimistic to say that the cold water will be 10 degrees C, but anyway, let us assume that the cold water is 10 degrees C coming into the faucet. So if this person here would open only the cold water, then what would happen is that we have then this 10 degrees C, which is about 50 degrees Fahrenheit. So this 10 degrees C water will go directly to the shower head. So we will then have 10 degrees C water coming out of the shower head. Of course, the poor person will say, "Brr, wow, that is really cold, that's no good, because I like it to be 30 degrees and not 10 degrees C. So this person will say, okay, I expected 30 degrees C, instead I got 10 degrees C, so when it comes to the output here, which is 10 degrees C, now I have an error of minus 20 degrees Celsius, and that is because I expected 30, instead I got only 10, so the output here is now colder with 20 degrees Celsius compared to what I expected. When it comes to the hot water, let us assume that the hot water is then being provided by a boiler, and this boiler is then providing an 80 degrees C hot water, which is 176 Fahrenheit. Similar to the example with the cold water tap, if our person opens only the warm water tap, then all this 80 degrees C hot water will go directly to the shower head, so our person will be of course screaming like Homer Simpson, "That's hot, that's no good." If we are thinking about the error, then we can calculate the error as the output, which is 80 degrees C minus our expected value of 30 degrees C, so overall the error will be plus 50 degrees C in this case. So what this person will do in order to get this 30 degrees C water out of the shower head is the following. First of all, he will open the cold water valve, then put his hand into the stream of this cold water and say, okay, I got an error of minus 20 degrees C, so the person will then also open the hot water as well, put the hand in again in the stream, and let us assume that now the water coming out is 20 degrees C. So now the person will compare this 20 degrees C with the 30 degrees desired or expected value and will say that now my error went down. Instead of being minus 20 degrees C, now it is only minus 10 degrees C. Because of this, the person will open the warm water even more, and this way sooner or later the output, namely the water which is coming out of the shower head, will reach this 30 degrees C. When the water reaches this desired temperature, or what we call the expected value, that is when the error will go down to 0. Using this real-life example here, I can then introduce you some of the basic properties when it comes to loop control theory without going into detailed mathematics and such. So first of all, the major components when it comes to this simple loop is first of all the inputs. So here we have the hot water and the cold water, which are the inputs. Then we have the output, which in our case is the shower head. The control element here is then the cold and the hot water valve. The controller itself is our person here, who is then controlling the hot and the cold water such that the output will be then stabilized. In order to stabilize the output, as I have mentioned to you, we are constantly monitoring the output and we are comparing the value of the output to an expected value. Based on the difference between the output and the expected value, we will then calculate an error, and then our controller will try to minimize this error. When the error what we calculate is really large, like in these two cases, then we know that we are very far away from the expected value. In this case, then our controller will then change or adjust these two valves, which are, as I mentioned, the control element, such to minimize this error as fast as possible and get close to 0. When we reach a 0 value of the error, then we are sure that our output is exactly our expected value. Okay, so let us assume that our controller here, or this person, have finally reached an error of 0, so the water coming out of the shower head is exactly 30 degrees. So now our person is then happily singing below the shower and all is great. and then suddenly someone comes along and then they will open another valve because, I don't know, they wanna brush their teeth or something. So it means that the incoming pressure either on the hot or the cold water side will change. Of course, as a result of this change in the input side will also cause a change in the output, which means that our error will no longer be 0, it will be a relatively small number, but nevertheless it will not be 0 anymore. Due to this non-zero error, our controller will then adjust the control element such that the output is then reaching exactly the expected value, so the error goes back to 0. This procedure, when the controller is measuring the output, it is comparing it to an expected value, and based on the error, then adjusts the control element, is what is being called a feedback. So the FB doesn't stand for Facebook in this case, but it stands for feedback. Namely, the controller will provide feedback based on the error, and the feedback provided will be done such that the error will then be reduced, or optimally it will go down to 0. Since the control element will be adjusted based on the feedback, which is then provided by the controller based on the output, we can then say that there is a feedback loop. Namely, there is a closed loop between the input, the output, the controller, and the feedback. After we have discussed this feedback loop, let us also think about, is this a negative or a positive feedback loop? In order to decide, let us just think about what happens when we are opening only the hot water tap. In that case, we know that the error will be plus 50 degrees C. As a result of this plus 50 degrees C error, our poor controller is then probably loudly screaming below the shower head. And now the question is, what kind of feedback will it provide to our control element? In this particular scenario, for us it is clear that the right decision what the controller should take is to then start closing very quickly the hot water valve. We can play the same game on the cold water side. So assuming that we have 10 degrees C cold water coming in and we are opening fully only the cold water tap, then we know that the output will then be very cold, so our error will be minus 20 degrees C in that case, which means again that the right decision from the controller should be to then start closing the cold water tap, because that way then the error will go down from minus 20 degrees C. Based on the previous discussion regarding the hot water and cold water examples, we can then conclude that our controller is providing a so-called negative feedback, and that is because using the negative feedback, it can then reduce this plus 50 degrees C error to 0 slowly, and also similarly it can reduce this minus 20 degrees C error. A negative feedback loop in a circuit is somewhat similar to the procedure of trying to train an animal. So let us assume that you have a dog and the dog have done something really bad. Then you will go and you will say, "Bad dog, don't do this again." So instead of doing a positive reinforcement, you are doing a negative feedback to the dog, and this way the dog will then learn that in the future it should not do whatever it was, like chewing your shoes or something. Similarly, in a circuit, our controller will then provide a negative feedback to our control element. Such type of negative feedback loops are used in almost every switch mode or linear power supply, and this is why today I have taken the time to then explain the individual components when it comes to the feedback loop. So now you should be familiar with the input, with the output, how are we calculating now this error, and based on the error, how is the controller sending the feedback signal to our control element. So after this short lecture on loop control theory, we are now back with the original schematics, and let us now try to identify what are the individual components when it comes to loop control theory. So here we have then clearly the input, and in this side we have clearly the output. The control element is the transistor itself. This is the element which is controlling how much power I'm sending from the input to the output side. We are using here this Zener diode, and that is providing the reference voltage, And as I have mentioned, we would like to have this reference voltage on the output side. So at the end of the day, this Zener diode voltage here is the so-called expected value. After we have identified these components, let us now think about it. Do we have any kind of feedback loop here? The response is no. Okay, then the other question is, are we calculating any kind of error based on the output and the expected value? Again, the response is no. In the current circuit, we are not calculating any kind of error, which means that we cannot provide any type of feedback to our power transistor. And this is the reason why the output will not be stabilized when it comes to this simple circuit. To build up a lot more stable circuit, we will then use an error amplifier, and we will use this error amplifier in order to provide feedback. Since this video is getting already very long, I will then discuss these components in the follow-up video. So please stay tuned in the next video in this switch mode power supply repair series. See you soon!